request the chief guests, guests of honor, and the plenary speaker to be on the dais. Thank you. I would now request Professor Avik Bhattacharya, IIT Bombay, to start the session. He is the general co-chair.
Well, good morning and a warm welcome to the inauguration of the India Geoscience and Remote Sensing Symposium InGARSS 2023. This is the premier regional conference organized in India by the IEEE Geoscience and Remote Sensing Society, GRSS. It's an honor to extend a heartfelt welcome to our esteemed dignitaries on the dais. Professor Sanghamitra Bandhyopadhyay, chief guest of the occasion. Professor Debabrata Das, Professor Debabrata Das, chief patron of InGARSS 2023. Dr. Mariko Burgin, President, IEEE-GRSS. Dr. Shiv Mohan, IEEE-GRSS India Liaison. Dr. Shubha Pandey, Scientist, Department of Science and Technology, National Geospatial Program. Dr. Jaya Nair, InGARSS 2023 General Chair. And Dr. Harini Nagendra, our inaugural keynote speaker. I also welcome our other distinguished speakers, Mr. Rashmit Singh Sukhmani and Professor Armando Marino. We are honored to have your expertise enriching our symposium. I also welcome Professor Carlos Lopez Martinez, GRSS Distinguished Lecturer. I would like to express our gratitude and extend our special welcome to our esteemed guests from the European Space Agency, Dr. Klaus Kipal, Dr. Francesco Sarti, and Dr. Magdalena Fitzek. Your presence adds immense value to this gathering, and we look forward to the insights and perspective you will bring to the conference. Thank you for joining us. So, having successfully conducted this series of InGARSS in 2020 and 2021, InGARSS stands as a vital platform for exchanging knowledge and experiences about recent developments and advances in geoscience and remote sensing technologies. This is particularly significant in the context of Earth observation and disaster monitoring, and addressing issues relevant not only to the Indian subcontinent, but also extending to a global perspective. So we look forward to enriching discussion, insightful presentations, and fruitful collaborations over the course of this symposium. And thank you all for joining us on this momentous occasion. So now I give it over to Shilpa and Harshit to conduct the rest of the proceedings. Thank you.
Gajananam bhutaganadisevitam kapittajambho bhalasara bhakshitam umasutam shurtaganadisevitam namami Vigneshwara pada pankajam agajanana padmarkam gajananam aharnisham anekadantam
Good morning, everybody. I'm Professor Jaya Srivalsan Nair from IIIT-Bangalore. I'd like to make the General Chair's presentation. So this is on behalf of the three General Chairs, that is Professor Avik Bhattacharya, who just spoke, and Professor B.S. Dayasagar, who is from ISI, Bangalore. Okay, so this is the agenda. So I would like to inform that this event is an IEEE-GRSS event, and this has been organized by IEEE-GRSS-Bangalore chapter. And it's an IEEE conference, and an academic partner is IIIT-Bangalore. Our chief patron is Dr. Debabrata Das, Director, IIIT-Bangalore. I would now request Professor Debabrata Das to say a couple of words.
Very good morning to all, and warm welcome to International Institute of Information Technology, Bangalore. In short, we call it as IIIT Bangalore campus for this momentous time for the IEEE INGRASS 2023. My deep regards to Professor Sanghamitra Bandhyopadhyay for gracing this occasion as the director of ISI Kolkata, and moreover, he is a wonderful researcher who has received one of the highest civilian awards of the country, plus the Infosys Foundation's award, and also the fellow of multiple topmost scientific association. You are the best persons to grace this occasion, madam. Thank you for coming for this. My special thanks to organizing chair, my esteemed colleague, Professor Jaya Nair from IIIT Bangalore, Professor Dayasagar from ISI Bangalore campus, and also Avik Bhattacharya from IIT Bombay. And also thanks to the TPC chairs and also all the other committee members for gracing this occasion. Thanks to all the committee members from different parts of the world and also India to grace coming to this conference. I welcome to Professor Mariko, the president of the INGARSS IEEE's chapter, Dr. Shiv Mohan, also esteemed guest, Dr. Pandey from DST. I quickly want to say only 2 points. IIIT Bangalore is a research institute with a world-class academic programs, majorly on computer science and engineering and electronics and communication engineering. And it has multiple center of excellence and various verticals of research, which you can have time, please visit them. And as being IEEE India Council Chair of India, let me tell you, IEEE India Council is the largest council in the region 10. It has 80,000 plus members, which is double in size than the China Council in that respect. So we have 13 sections and in this country and 15 subsections, and Bangalore section is the second largest in the world. So where you are sitting in this Bangalore city, we are the second largest sections of the world, and also we are very close to being number one very shortly. And I wish this conference a grand and successful with the leadership of the chairs. And thank you, Professor Jaya and Professor Dayasagar and Avik. Thank you.
Thank you, Professor Das. So we'll move on to giving the report for the conference. So the organizing committee is headed by the three of us. It's a 40-member organizing committee. It is across 13 portfolios. We have a pan-India team and one foreign member, and it is across several IEEE-GRSS India chapters. We have a 13-member international advisory committee. Our sponsors, we are very thankful to them. They have been a backbone to conduct this event in a very grand way. So we would like to thank our co-sponsors, IIIT-B's Minro Center. There's a Machine Intelligence and Robotics Center by the Government of Karnataka, the Department of Science and Technology, Government of India, Emphasis Foundation with the Center of Excellence at IIIT Bangalore for Cognitive Computing, and SATSURE. ISRO is a silver sponsor, and NRSC is our double bronze sponsor. We have bronze sponsors, HALG, Galaxy, and IIT Tirupati, TIH. Thank you. So thank you to our sponsors. Our partners are, academic partner is IIIT-Bangalore, and our knowledge partners are DST, Geospatial World, Chamber of Commerce, and IIT Tirupati, TIH. Our technology partners are IEEE Bangalore section, Open Geospatial Consortium, and Let's Talk Spatial, which is a local meetup group. So our technical program has been very competitive, and we have received 309 submissions in all, of which the research track is 268. The total number of acceptances is 129, and our acceptance rate ratio is 48%. Our TPC chairs are Dr. Ujjwal Verma, Dr. Karthikeyan Langa, and Dr. Saroj Meher. Our doctoral colloquium chairs are Dr. A.M. Ramya, Dr. Sangeeta Chowdhury. Our industry track chairs are Dr. Ramakrishna Raman, Dr. Naresh, Dr. Shashikumar, and Dr. V.S.S. Kiran. So this is a breakup of all the topics that we have had the papers in. So we have had the largest number in general theme applications. So the blue indicates the accepted numbers, and the orange indicates the rejected numbers. So this is the region from which the papers have come. So we have the largest number, obviously, from India, and then we have a few from United States, Spain, Italy, Australia, Canada, China, etc. We have 4 tutorials, chaired by Dr. Shyamlal and Dr. Shilpa Suresh. The 4 tutorial sessions are, the first one is on monitoring land use, land cover changes with Google Earth Engine by Mr. Ujjwal Gandhi. Second one, when deep learning meets Earth observation by Mr. Rakshit Satish. The session 3 is on SAR, polarimetry and applications for current and new missions by Dr. Carlos. And the 4th one is standards for geospatial analysis ready data products by Dr. Sumit. We have 3 plenary keynote speakers. The first one is going to be today. So Dr. Harini Nagendra is going to speak about the sky is not the limit. Mr. Rashmit Singh Sugmane is going to speak about the evolution of AI/ML, role in Earth observations analytics. Dr. Armando Marino is going to speak about the new trends in polarimetric SAR, POLSAR. We have an European Space Agency co-located workshop, and this is the agenda. We have distinguished speakers at the co-located workshop. And the topic of the workshop is in polarimetry. We have a space missions overview tomorrow. This is an overview of all the space missions in the international scenario. So we have Dr. Alberto Moreira from DLR Germany. We have Dr. Prakash Chauhan, the director, NRSC, representing ISRO and NRSC, and Dr. Klaus Keipel, representing ESA. We have IEEE-GRSS events. We had the distinguished lecture as a pre-conference program yesterday. We have a GRSS idea event, which is for the young professionals, and we also have the GRSS Young Professionals Funded Challenge. We have several community events, women in engineering, diversity, equity, inclusivity, and young professionals. We have a DST-led STEAM session, that is the science, technology, engineering, arts, math session on spatial thinking pedagogy, which is on the last day, December 13th. We have sponsors events. We have plenary short talks, exhibits in the basement, sponsors panel discussion, NRSC and ISRO talks, and IIT Tirupati's TIH NAVIC talk. So we have had 466 registrations in all. 294 will be here in person in the next starting today until Wednesday. 172 are going to be joining us online. There are 175 student registrants. And being a GIS conference, it is not, it won't be complete if you don't put up a map and show where the registrations are from. Right, so we have that. So a large number from India, so that's 406. I would also like to make a few special mentions here. Our mementos that will be presented to the guests and speakers are by Diya Innovations. They create gifts by people with intellectual challenges. So it's a social NGO. So we have used them for our mementos. Our registration kit is designed by Prakriti Goswami, who is a student of Integrated MSc Environmental Science, School of Earth Sciences. So if you're enjoying the kit, it is made by a student, and a very creative student who is also an environmental activist. And last but not the least, the conference website and the designs are built by our own Amrit Kiran, who is with IIH's Geospatial Lab, and he has done a wonderful job. And the program guide, which is superly stunning, is made by him as well. So I would now like to take a moment to introduce Dr. Mariko Burgin, who is the IEEE-GRSS president. She's come all the way from California to attend the conference. That shows how significant the conference is. It's a regional conference, IIEE-GRSS conference. I would now request Mariko to speak a few words.
Good morning, everybody. Thank you so much for having me. It is a great honor to be here at this inaugural event. I came all the way from California, and I'm really happy to be here. I'm the third president of IEEE-GRSS who made it apparently to India, so hopefully more to come in the future. I want to keep this short, but I did want to say my heartfelt gratitude to the local organizing committee for their passion and dedication to organize this event, all the speakers, all the fantastic events that I've been seeing here before. I really look forward to it, and I hope I can also meet some of you, the attendees here. On behalf of IEEE-GRSS, I welcome you to InGARSS, and I hope you have a most inspiring conference. Thank you.
I would thank you, Mariko. Now I would like to introduce our guest of honor, Dr. Shiv Mohan, who is the IEEE-GRSS Liaison. InGARSS series was started by him in 2020. Unfortunately, the pandemic hit and it had to be online. So 2020 and 2021 were online. This is the first time we are having it as a hybrid event. So we would now like to request Dr. Shiv Mohan to also speak a few words.
Good morning to all of you. I feel privileged to be part of inaugural ceremony of InGARSS 2023, I think, which is the first of in-person conference and mix of both. Earlier conferences were mostly, both the conferences were virtual mode due to COVID situation across the globe. Now, after the COVID situation is over, I see a dramatic change in the scenario of remote sensing community. There are large number, variety of data set from variety of platform and in advancement of data analytics. So the user requirement and user expectation are very high. So I see that this conference will provide a platform to discuss among the delegates the suitable form, suitable method, and the data analytics. Thank you, and I wish you will enjoy the InGARSS 2023 and give us feedback so that we plan a better 2024 InGARSS. Thank you again for coming in this.
Thank you, Dr. Shiv Mohan. Now I would like to welcome Dr. Shubha Pandey. She is a scientist at Department of Science and Technology, GOI. She represents the National Geospatial Program. She spearheads a lot of the activities there. She is very passionate about capacity building in the GIS space. So we are very happy to have her here. Dr. Shubha Pandey, you could speak a few words.
Hello. A very good morning to all of you. Indeed, it's a great pleasure to address all of you from behalf of National Geospatial Program Division of Department of Science and Technology. So I would like to mention two important achievements from DST from last 2 years. One is issuing the geospatial guidelines, which has opened up this sector enormously. And second is issuance of the National Geospatial Policy. So the policy is very comprehensive and citizen-centric. So from government side, there's a lot of push to this sector. So I'm hoping with support of all of you, we can make geospatial, we can make a world leader in geospatial sector. Thank you.
Thank you so much, ma'am. Inspiring. So now I would like to welcome Professor Dayasagar to introduce the chief guest and welcome her to the event. Thank you.
Nice to have an opportunity to introduce my director. She is my boss. And Dr. Sanghamitra is a senior professor and the director of Indian Statistical Institute since 2015. And as Professor Debabrata Das mentioned that she has received an Infosys prize. I think she is the only woman engineer so far has received the Infosys prize in engineering sciences. So she is highly decorated scientist and an academic, and of late we all realize that she is also a great administrator, and she makes all of us on toes all the time. And so we all work very hard under her leadership. And I was actually given 3 minutes time to speak about her, introduce her, and actually it requires 30 minutes to read out her, the most salient features of her biography. So she has been, in addition to Infosys Prize, she has received TWAS Prize, the World Academy of Science Prize in Engineering Sciences, and she has been conferred fellowship of the World Academy of Sciences, and she has been a fellow of Indian National Science Academy, Indian Academy of Sciences, and National Academy of Science India, and Indian National Academy of Engineering. And she received much before, early last decade, Shanti Swarup Bhatnagar Prize. Again, she was the first woman engineering science awardee. And then Professor Sanghamitra Bandhyopadhyay is also a member of Prime Minister's Scientific Advisory Committee. And then she's our chief guest today. And then let me stop it here, and then let us allow her to speak a few words. Yeah.
Thank you very much. Good morning to all of you. And thank you, Professor Dayasagar, Professor Jaya, for inviting me here and for your nice words. And thanks to the director of IIIT Bangalore. Somehow, IIIT-B and IIIT-B, these two get I get very confused.
The domain also only one eye difference.
One eye difference. Absolutely. Absolutely.
More egoistic and less egoistic.
Huh?
Three eyes and
Three
two
eyes. So we were joking yesterday that it's too much egoistic. So one more eye. One more eye. But yeah, it's a pleasure to be here this morning. I do not directly belong to the area of geosciences and remote sensing, but it so happened that during my PhD days and even after that, I have primarily been developing various clustering and classification methods. And one of our favorite data sets, two data sets, were these images. One was an image, satellite images, image of Calcutta and an image of Bombay. And what we competed was, you see, Calcutta had this river passing through, and there's a bridge. Who can detect that bridge? Which method detects that bridge? And that is how we justified that, okay, my method is better than others, etc. And Bombay also, there was this airport and other things which we had to detect using our clustering and classification methods. So we did a lot of papers, including in Transactions of Geoscience and Remote Sensing. These methods were published there also. At the same time, what we were doing is we were just looking at the data just like any other data, right? So for every pixel, we had the, in the IRS image, we had RGB and infrared, I think. Four values were there for every pixel. So our data was like, it was I think 512 by 512 image. So it was just like a matrix, okay? 512 by 512 into 512 rows and 4 columns. So that it became just any other data set for us. And we did clustering, we did classification, etc. And then one work which we did, which was quite, it benefited quite a bit, because unlike other data sets, the image data gave us also spatial information. So it's not that this row and this row, they are totally independent. They may be neighbors. So that pixel neighboring information was also built into the classification and clustering method. And that improved performance quite significantly. So that has been my brush with geoscience, with remote sensing data. But I do realize that this domain is so extremely important. We have to, I was talking with Dr. Pandey just a while back, that it is time now to actually identify, sit together, people from different expertise, from different disciplines, to sit together to identify a few problems that we want to solve in the country and brainstorm with people of different expertise. So that is necessary not only in this domain. I work primarily with artificial intelligence and machine learning applied to the domain of healthcare. But it's not only application. What I take pleasure in, being a computer scientist by training, is developing algorithms. And we've developed many algorithms which we apply to biological data, have got very good results. But those methods can be applied anywhere. And now everybody is hearing about this deep learning, generative AI, etc., which to a large extent is also, it's also bothersome in the sense that everybody is concerned now where this generative AI is taking us. And there is a worldwide debate that maybe even the people who developed the deep learning, the 3 machine learning researchers, they themselves are divided into where is it heading, whether we should for the moment stop funding in this area, put all the policies and regulations in place and then move ahead. Because things are becoming more and more, what should I say, even human beings are under existential threat now. Or in the near future that is going to happen, whether the machines will replace human beings. I don't think machines will replace the machine and the human. They have to work in coordination to solve real problems in real time. But in India, what we lack very much is Indian data. The researchers of the universities, of the colleges do not get Indian data. Only some few institutes have their own data in silos. We need to break these silos and come together, have Indian data. That is true even in any domain that you can think of. Healthcare, there is no Indian data available. But individual institutions have their own data, which is not a good way of doing science. So we have to, even in this domain, I don't know what could be some pertinent problems, some pertinent real life problems that we need to solve, that you as domain experts will be able to put your finger on. But we who come from the AI, ML area and other people from other areas, I think we need now to sit down together to identify certain national level problems and keep them out in the open. While a group tries to solve those problems, they should also be out in the open so that any undergraduate student can also take up parts of that problem and solve it. Maybe some extraordinary things may come out of those things as well. So that is, I think, the way to go now, and I'm sure DST, Department of Science and Technology, is already leading it. We have the National Research Foundation, which is going to come in. It's, the policies and everything are getting made. But that will come in sooner than later. So a lot is going to change. Private sector has to come in a big way for funding Indian research. Indian research, as we all know, the science, the percentage of GDP that is spent on research and development in India is much lower than compared to any other developed country. And we have our colleagues from other institutions outside the country, including European Space Agency. We need to brainstorm and figure out how they do things and what we can learn from them, and in turn what we can also give them. So this is very important, this cross-border talk, and because finally geoscience, remote sensing, or whatever you call it, there is no boundary to that. There's no political boundary. All boundaries are political. But the wind will not know that here India ends and some other country begins. So thank you very much. It's a pleasure and honor to be here with all of you. And I do hope you all have a very nice time, and I will also be here for some more time. And I also get to learn from what is going on in this domain. Thank you very much.
Thank you, ma'am. And so one fellowship, very prominent fellowship, because it is IEEE-GRSS event. She has been an elected IEEE fellow almost 10 years ago, I think, from the Computational Intelligence Society. Thank you very much, ma'am, for being here with a short notice. Yeah, so the keynote, another plenary keynote address is by Professor Harini Nagendra. So when we were actually discussing all three general chairs and who should be the potential person to give a plenary note, plenary talk here, I have mentioned the name of Professor Harini Nagendra, though I have never met her, but she's like a celebrity scientist, and she's so popular in literary circles, and also her recent book on shades of blue, and which is very popular. And I have been struggling to explain rivers, mountains, valleys, pits, and all the terrestrial surface through mathematics for the last 25 years. But the way she has explained, and it has reached to the audience, and in a big way, so we have to really appreciate her efforts. And she has been a professor at Azim Premji University, and she had her education BSc from Bangalore University, Masters and PhD from Indian Institute of Sciences, and she works on sustainability development goals. And then she is an eminent ecologist, and she uses remote sensing as one of her main tools. And she received very prominent prizes, one from the National Academy of Sciences USA, that is, I know Kojarelli Prize is a very prominent prize for ecologists, and another one is Eleanor Rostrom Senior Scholar Award and the Clairvaux Award, and she has been an elected fellow of Indian National Science Academy. She is an FNA, and very recently she has been elected as fellow of the World Academy of Sciences, and which are all great achievements from a scientist of her stature. And so I think with this, let me not take too much time, and then she will talk about sky is not the limit, and then this one, and then the other thing. So let us welcome Professor Harini Nagendra. Thank you so much.
So while the talk is being set up, we thank you all for being here for the inaugural ceremony, and we are hoping you will enjoy InGARSS 2023.
Good morning, everyone, and thank you for a big thank you to IIIT and to the organizers of IEEE India Geoscience and Remote Sensing Symposium. It's a great pleasure to be here and an honor to be the first keynote speaker. I have I hope you can see this behind, yes. So it's a longish mouthful of a title, which I will not try to read out, but I hope you'll pardon me. I'm going to do a partly autobiographical discussion of 30 years of work in remote sensing in the field of GIS and remote sensing in India. And I think through that, I want to give you some thoughts on where is the role of remote sensing in the Anthropocene through some personal experiences, but hopefully things that can be relatable to others, because the field is now becoming very interdisciplinary, as you yourself said. Our chief guest just told us that her PhD work was on clustering and looking at remote sensing data, and some of the work that I did during my PhD, because it was also at the time when software didn't exist for much of these things, was also to explore clustering techniques of various kinds and statistics. I think the field has come a huge distance from then. I know, for instance, there's a special session on polarimetry and many other approaches of using remote sensing along with AI and machine learning and other approaches we could not have dreamed of when I started. But I also think that we're a world so much more in crisis. As a person who teaches issues of ecology to students of development, students of environmental science, I myself can see the situation having changed, because let's say 10 years ago, a lot of our students would come and say, why are you teaching us issues of the ecology and environment to students of, let's say, development or social sciences or something else? We left biology back in the 10th. Nobody says that now. Everyone wants to know more, and we realize that issues of climate change, tipping points, biodiversity. I'm sorry, this is going to be a bit of a gloomy talk. I'll get away from that to the science. But we can see the world changing around us. We can see the dangers of collapse on many social, ecological, environmental fronts. We also see that this is linked to other issues like human rights, wars that we see, struggles for water, and the future ahead is really something that is going to be challenging. And I think that calls for all of us as scientists who work with data in one form or the other to get more engaged with society in multiple forms. So this is really what I'm going to talk about, my own journey, but with this background of how we all need to rethink our approaches for engaging with society going forward. So the sky is not the limit. We are in the era of the Anthropocene, where urban growth leads to major human transformations of the Earth's surface. And there are many markers of the geological area called the Anthropocene. It was, of course, a term, for those of you not familiar, it started as a term used by global environmental change scientists. And geologists for a very long time were resistant to calling this an era of the Anthropocene, because they said, what are the markers? But you have a number of markers. For instance, there is now more plastic. The weight of plastic and the weight of all human-made substances on Earth is more than the weight of all biological materials on Earth, human beings included. Okay, the number of chicken farmed for industrial production is much more than all the species that you have, all the individuals you have of all species, right? So these are the kinds of impacts we have on the planet. These are the kinds of global transformations we have, and this is why we are truly in the era of the Anthropocene, and which is why geologists also more than a decade ago finally declared that we are in the era of the Anthropocene. And of course, one of the major markers of the era of the Anthropocene is the impacts on the land surface. It's also there in the oceans, it's also there in the subsoil, it's also there in the climate. But one of the biggest, most visible impacts for us as geoscientists that we can relate to are the human transformations of the land surface. I didn't begin with the big scale. I began my career as a microbiologist. I did my undergraduate degree in microbiology. I was at the first batch at the Indian Institute of Science of integrated PhD students, which meant I did a master's also in molecular biology and didn't like it. And I had the great good fortune of listening completely by accident to Professor Madhak Gadgil, one of India's best-known ecologists, give a talk, and decided to switch fields. So I came into the field of landscape ecology sideways, but it was a field I loved. I loved being outdoors in the landscapes, working with people, and it required a shift. I had the good fortune of not being trained in any of these techniques, not in statistics, not in remote sensing, not in computer science, not in landscape ecology, not in ecology. And because of that, I had to do a lot of self-training, my own courses, my own reading materials. Two of the books that were extraordinarily influential, and this is especially for the younger people in the audience. I know we don't often talk about classics. We go off very deep into specific technical issues these days. Again, I think I was fortunate to be trained in a different era 30 years ago, where a lot of conversations between disciplines were so much more possible. Somehow, I think we have become much more siloed in our thinking over time. But these are two wonderful books that anyone doing geospatial work should look at. One is Landscape Ecology, Principles of Landscape Ecology by Formon and Godron. This is a very fundamental book in the field, which talks about issues of why it's not just enough to do studies of land cover change, but look at patterns. And from patterns of change, infer underlying human processes and geological processes that lead to these changes. Right? So the pattern and process link. And the second is the fact that anything we do with remote sensing data is inherently hierarchical. How do you think about hierarchy? This book, Hierarchy Theory, it's out of print, very difficult to find, but can be still found, by Allen and Starr, is brilliant because it helps you think about hierarchy in biological structures and the fundamental ways they ask you to think. For instance, one of the things I took away from this book, which is fundamental to a lot of my work, is if you're looking at a level of analysis, always look at the hierarchical implications of the level just above and the level just below, because those are the two important levels that play back and forth in your analysis.
Do you
of the books that were extraordinarily influential, and this is especially for younger people in the audience. I know we don't often talk about classics. We go off very deep into specific technical issues these days. Again, I think I was fortunate to be trained in a different era 30 years ago, where a lot of conversations between disciplines were so much more possible. Somehow, I think we have become much more siloed in our thinking over time. But these are two wonderful books that anyone doing geospatial work should look at. One is Landscape Ecology, Principles of Landscape Ecology by Mohan and Godreau. This is a very fundamental book in the field, which talks about issues of why it's not just enough to do studies of land cover change, but look at patterns. And from patterns of change, infer underlying human processes and geological processes that lead to these changes, right? So the pattern and process link. And the second is the fact that anything in remote sensing data is inherently hierarchical. How do you think about hierarchy? This book, Hierarchy Theory, it's out of print, very difficult to find, but can be still found by Allen and Starr, is brilliant because it helps you think about hierarchy in biological structures and the fundamental ways they ask you to think. For instance, one of the things I took away from this book, which is fundamental to a lot of my work, is if you're looking at a level of analysis, always look at the hierarchical implications of the level just above and the level just below, because those are the two important levels that play back and forth in your analysis. But anyway, again, for the young people starting out, I think what I would say is read the classics, read something that is alive to your field, see how they intersect. And my fortune, as I said, was to come in not being trained. And so I could read all of these to figure out what I wanted to do. And Professor Gadgil was, I think, a brilliant mentor because he really encouraged the fact of creating something new. Let's look at something we both don't know. Let's figure it out as we go along. So I started in 1993 when digital remote sensing was just coming in as a field into India. And of course, ISRO was doing a great deal of work on that, but very few institutions outside of ISRO were doing work. And so at the Indian Institute of Science, we purchased 53 images of the Western Ghats, which is one of India's biggest and actually the world's most important biodiversity hotspots. India had then just signed the Convention on Biological Diversity, which committed the country to monitor its own biodiversity and changes over time. And we knew that we couldn't do this through field plots alone. How can you go across the entire Western Ghats and have biodiversity monitoring? Professor Gadgil had also got a grant from the Tree Foundation at that time to work with about 30 different undergraduate and master's colleges of botany and zoology across the Western Ghats. So we said, why don't we set up a hierarchical sampling method inspired by these books? That you will have these college professors and their students work in different plots. And then we use remote sensing to go from the gap to the stand to the landscape to the ecoregion scale. So we did this hierarchical clustering algorithms, which let us classify the entire Western Ghats and capitalize on the fact that you had satellite remote sensing and digital image processing using landscape ecology. Now, we didn't have access to the software that people use very routinely these days. So I used a lot of the GRASS software. The US Geological Society had GRASS software, which meant I had to learn C++ and coding to figure out what the software was doing and run our own statistical clustering algorithms to integrate into this because much of it simply wasn't available. It was a fascinating time because I think we really saw at that time for ecology what the opportunities of remote sensing were to link to ecology. And some of the work that came in was very multidisciplinary. It allowed me to link ecology with remote sensing with the ideas of spatial statistics. And this was my PhD work, looking at how you actually do biodiversity monitoring in a hotspot, which is the Western Ghats. And like I said, the hierarchical monitoring protocols we laid out were excellent and then were systematically used across the Western Ghats. So it was very satisfying for me. I came into ecology partly because I couldn't sit in the lab. Molecular biology was just not something that I wanted to do, but also because I came into the field of ecology with the idea of doing something that was very relevant. I mean, in India, science is expensive. Science requires a lot of public expenditure of money, which is taxpayer money, and we are a country with a lot of challenges. So very much I came into this area of science very much with the idea of how can we do science that contributes to societal challenges. And therefore, multidisciplinarity became important, linking these fields of science. This is the kind of work we did. So one landscape where you had high levels of classification into different ecosystem types, then link that into different classifications. This is the entire Western Ghats that you can see. And then try and look at the differences in species composition. So we were trying to see if you classify these
data differently is at which level can we actually see significant differences in species composition. If your different ecosystems classified are significantly different in ecosystem composition, and then the clusters at the next level and the next level are also different, you can use this for monitoring over time. And you can identify hotspots of change, areas where species are being transformed very rapidly, and then go to the field. So you optimize scarce resources, human resources, money, time, and you can actually go there and optimize where you should be looking for what kinds of change, which helps then India contribute to the CBD and the commitments the country made to the CBD. Right? So there were a number of papers that came out of this. One review, for instance, which is still very influential, which was the first one on using remote sensing to assess biodiversity. This is a long time back. This is in 2001. And satellite imagery for monitoring biodiversity in with PNAS and Journal of Applied Ecology. And this helped a lot because in terms of my own satisfaction of getting to a point where you have these protocols that can contribute. But I realized that we found a lot of changes. We found that there were, of course, there was a lot of forest degradation in the Western Ghats. But we also found places where forests were recovering, forests were coming back. And we didn't know why. And a lot of the whys are human directed. Just like the why forests are degrading or deforesting is because of human action, a lot of the places where forests were going back was also because of human action. Right? Either human land use had been abandoned, intensive land use had been abandoned, or there were places where people were actually actively protecting forests and regenerating them. And I realized that was the next step. Not just to monitor change passively, but to understand what human beings are doing to protect these landscapes. And therefore, sort of as a self-confessed optimist, I think one has to be an optimist working in these areas which are otherwise can be very dismal. One must understand what the conditions that can facilitate human beings to be positive agents of change. We have so much talk about how human beings do negative things, and there's a lot of that. But what is facilitating conditions? And those conditions have to be social and ecological. They're not just social, they're not just ecological, they're not just geographical.
And they're not the inverse of the conditions that stimulate deforestation. Very important. For instance, you put roads through a landscape, you get deforestation. We all know this. If you remove the road, first of all, you're not going to remove the road. How will you remove a road that exists? But let's say you remove the road. Does that mean the forests grow back? Not always. Sometimes the road has led to other changes that are fixed, that you can't change just by pulling out this road, even theoretically, right? So the factors that stimulate reforestation have to be very different from those that stimulate deforestation, and one needs to study that more systematically. And this is something I set out to do in 2000 when I moved to Indiana University to work with Professor Eleanor Ostrom. Many of you may have heard of her, the first woman to ever get the Nobel Prize in Economics, and a lot of her work was on communities and community institutions. I moved to work with the International Forestry Research and Institutions program there at Indiana University to lead their South Asia Center, which is working in India, Nepal, and a bit of Bhutan, and also working with other colleagues in Guatemala and Honduras. And there began my second stage of work, which I would classify as more interdisciplinary. What for me has been, and of course there are debated definition differences between this. For me, what it has meant is when I was working on multidisciplinary approaches, I took A plus B plus C and put that together. At the Center for the Study of Institutions, Population and Environmental Change called CIPEC, which Professor Ostrom and another Professor Mohan, who is an anthropologist working in Brazil, had put up. They were looking at getting people together to do a lot of crosstalk. So there was me, the landscape ecologist, there was a specialist in GIS and remote sensing, an anthropologist, someone doing ecological econometrics, and we all had conversations together, and it took us 8 to 10 months to finish these conversations and get on a common place. And I'll give you an example of what I mean and how this matters again for space. The anthropologist colleague that we had was looking at one Honduras small indigenous community living at the base of Selake National Park. And she, because anthropology is all about the particular, the specific. And so she did not want to translate her work from that village to a village that is, let's say, 5 kilometers from her village. It is against the basic principles of the way her field is set up. Right? For us, GIS and remote sensing is all about extrapolation. You take data from 5 places, you extrapolate it to the whole landscape, and you're looking for what belongs and what doesn't belong with some degree of confidence. And there's a difference, there's a fundamental difference that you require a lot of conversations to get interdisciplinarity to flourish, because you first need to build that trust and understand that when you talk about scaling and someone else talks about scaling, they might be thinking of it in completely different ways and might be philosophically opposed to the idea of scaling to begin with. Right? So that takes a lot of conversations. And these kind of conversations led to a lot of interdisciplinary thinking, which I think is extraordinarily important in today's day and age again, because often we talk about projects, we write projects about interdisciplinarity, we get funding for interdisciplinarity, but we don't build in that time for the thoughtful conversations that interdisciplinarity really requires. So when we finally do the project, we're running and we parcel it out saying, this work project is yours, this one is yours, this one is yours, can I combine these and get a picture? And then you don't get transformative change, because you're still not discussing with each other. You're not coming up with something new. You're still coming up with A plus B plus C. But I worked in different places. I worked with in Nepal and looking at something that is really fundamental that Nepal did. So in the 1980s, there was this lot of talk about the great Himalayan degradation. And the idea was that Nepal, being a poor country, was cutting down all the forests on the hills. Entire Nepal would be denuded, land would come down, mud would come down, it would get into the great rivers like the Brahmaputra. We would have landslides in Bangladesh, in India, all the downstream countries, right? And this would be the great Himalayan collapse, which would be disastrous for the world, and the entire breadbasket of India, Ganga, Brahmaputra valley would be affected. These were exaggerated. There was a lot of exaggerated claims made around this time. But interestingly, what the Nepal government did at that time was instituted a very, very progressive program of community-based forestry, along with UNEP, which funded it systematically for about 10 years, and a number of other organizations. They created community forestry in different parts of Nepal, where they handed over forests to the communities. Communities would protect them, stop grazing, encourage the forest to regrow, and then communities would get some share of the profits that you could use through ecotourism, through collection of non-timber forest products. India, of course, had its similar analog later in Joint Forest Management Program, and so did a number of countries. Nepal was really one of the first that experimented with this program. I looked at that, and one of the things, again, that geospatial technology can be very useful for was to look at the UNEP-based park forestry program, which is the ecotourism version of community forestry along the park. And what you can see is the Chitwan National Park. So this is the riverbed, and south of this is what was then the Royal Chitwan National Park, is now the Chitwan National Park, very well known for its rhinos. This is the park main gate. You have community forests, the traditional community forests up in the hills. This is the plains, you have the Rapti River, and these are the ecotourism parks, right? So ecotourism parks here, community forest parks up there. And this community forestry program was widely talked up by FAO, by UNEP, as being very, very successful in getting a lot of money to the communities living next to the village park. So what they would do is they would act as a natural buffer. Parks need a buffer. You have wild animals in the park. You can't come out and have extreme density, high intense land use. It's not good for the animals. What these communities were encouraged to do was to stop all grazing, stop all collection of timber, regrow their forests, which they did. And the idea was then they would get tourist income in exchange, because tourists would come to visit the national park. They could go on safaris with village communities. Their youth could be trained in bird programs and things like that. And the money would come back to the villages, not to people, but the villages could use this for libraries, for schools, for health infrastructure, to build up their social capital, a number of things that they needed. And always, always, you would find the story of this one community, which is the Bharatpur community, which was right at the park main gate, and they were getting, way back in 2002, 65 lakh Nepali rupees, which is a lot of money. It was several, maybe, I don't know, $100,000 a year, quite a lot of money for a poor Nepali village. What we could show through GIS, I mean, this is something that struck me as soon as I went there. You need not, so this is why, one needs to keep one's eyes, ears open, because it was fairly obvious when you went there, that you could come here and go to this park, or you could go on this really bad jolting road, which would actually not be that far, but it could take you 4 to 6 hours to get here because the road was so far bad. Down the river at the end, all the way to the last place, and hire tourists there. why would you do that? Why would any tourist who came go 6 hours on this bad road and go to the last village? So of course, no one went to the last village, and while the first village was getting 66 lakh rupees, the last village was getting 20,000 rupees. It's a factor of close to 1,000-fold difference, right? So they're getting about 1,000th of the money that the village near the gate is getting. And so you realize that the approach, when you say that everyone is talking about one village and saying this is such a success, we should scale up, again coming back to the idea of scaling up, there is geography that impacts this, there is society that impacts this, there is the willingness of tourists and their behavior to impact this. And so you can't have scale-up programs just based on success of individuals. You have to look statistically at what's going on in the entire ensemble. Right? So that's an example of some of the work we did in Nepal. There's much more. In India, we looked at, again with colleagues working on the Tadoba Andhari Tiger Reserve. This is the reserve. And there are 6 villages. There were then 6 villages within the park. One has since been, 2 have been resettled. And 53 villages around the park. And a lot of the focus of the conservation community was on moving these 6 villages which were in the park, indigenous forest communities, outside. Now what I was able to do along with an economist colleague, looking at talking to the villages in the park and quantifying their impact on the park, along with remote sensing data, high spatial resolution data, as well as biodiversity data on the trees and on the regeneration, actually fine scale examine the differences in the communities within the park and the exterior of the park. So the 53 villages around the park were not tribal. They were harvesting forest products at a very high scale, getting grazing at a very high scale, and doing all of this for commerce, for commercial use, right? Because there's infinite growth of the towns. I mean, India is fast urbanizing, and I'll come to that, but this area is really urbanizing so fast, there's a huge demand for forest products of various kinds, and of milk, and of meat, and things. So the 53 villages outside are constantly coming into the park, and their pressure on the park is very high. The 6 villages within, because they don't have roads, they don't have access to healthcare, they don't have any benefits, are actually harvesting for their own use. It's subsistence use. There is some impact on regeneration, which is why we sliced and diced it, the data from trees, the data from the next layer, and the data from the seedlings. There was some impact on regeneration because of their goats. They were eating up the seedlings. But it was nowhere near as bad as the impact on the 53 villages in the periphery. And so what our advice was to the government and the conservation communities and the NGOs working there was change your strategy. Make the villages at the periphery your partner. You can't relocate them. They're in legally acquired land. They live outside. You can't change the fact that the market is going to demand access. And realistically, the government can never have the resources to patrol this entire neighborhood. I mean, we can't. Our parks are too large. There's too many places where people can come in. People have to be partners. And so how do you make the people partners? And that was part of the discussion. Right, so there's some work here which turned out to be very important. And this is again some of the results that came from here. But I'd also like to talk to you about the interdisciplinarity that I was talking about with the colleagues who are the ecological economists and the anthropologists. And this was in Selake National Park in the Honduras. So Selake National Park, this is a digital elevation map. You can see the green cover, which is really on the hills, and you can also see how steep this is. And the area around is extremely dynamic because you have communities, again, indigenous communities in the Honduras region, which practice shifting cultivation. So we saw a lot of changes, and we couldn't figure out what the processes were. And again, looking back at my book, the Landscape Ecology Formon book, there was something that was very fundamental that I wanted to look at, which is how do you link pattern and process, landscape pattern, spatial pattern to underlying human processes. So we looked at the park boundary, the core and the buffer, imposed the elevation locations of main roads, towns on them, looked at the accessibility landscape. Where can people go in and cut the forest? Where would they go in, given that these are the roads, these are the towns, these are the other places? Overlaid the change trajectories. We had accessibility clearing from 1987 to 1996 to 2000 to 2004. So every 4 years we had a change trajectory, and we overlaid all of this. And then put these landscapes trajectories in a larger, this is just a 3-dimensional graph, but we actually had a multi-dimensional graph where we had elevation, slope, distance to road spaces, and the different trajectories at different time points. So we started seeing that there were 2 different things that was going on. Between 87 to 91, we saw a lot of deforestation, as we would expect, deforestation in the low slopes, the accessible areas, a lot of reforestation in the inaccessible areas. So obviously people are clearing where they can go. The second time period, so 96 to about 2004, you suddenly start seeing deforestation in the high mountains and a lot of regrowth close to where people live. And it made no sense to us. So we started trying to understand why. And then we used landscape ecology. We said, let's say that the size and the shape of patches indicates economic function. So if you have a long patch of deforestation next to the road, you know it's logging. If you know it's a small patch that is repeatedly cycling, because remember we had 4-year data, goes forest, non-forest, is shifting cultivation. If it's a very large patch of reforestation, it's likely, and especially close to the road, it must be abandoned logging areas. Because, so we're using deduction to say this is the patch, this is the spatial pattern, this is the adjacency, this is what the human process is going to be. And then we calculated a number of landscape metrics and associated them with elevation, slope, and distance to road. I won't go into the details. You can see I'm happy to share papers. But what we found was there was a flip between the two stages. Initially, people were deforesting in the accessible areas and also trying to do agriculture in some of these places which they could access. But two things happened. In 1996, shade coffee became very big. So organic coffee became very big in the US, and everybody started talking about shade-grown coffee, which was very ecologically important. So they started, the Honduran government said, we will build a road in this inaccessible national park where nobody is supposed to build roads. We will build you a road because this is part of the Honduran government's economic growth program. And we will allow you to get to shade coffee protect, which means clearing the forests. We couldn't see the clearings for the coffee because they were below the trees, so you can't see them with remote sensing, but heat picked it up. And this is again where you can be creative. So we started looking at heat indices with Landsat. And you can see more heat under those areas where you have coffee, right? But what happened was people then, and also fertilizers came in, pesticides came in. So the small patches of agriculture, which were rocky areas, unproductive, they started abandoning them. The forest grew back. So that's why accessible areas you found forest recovery, inaccessible areas you found deforestation. And this, we could never have got to this if we didn't have the mix of landscape ecology, pattern, accessibility, looking at heat, and all of this. And importantly, without the anthropologist colleague who understood how people think and behave in this landscape. And this was important because the percentage of change was very low, but the impact on biodiversity was huge because this is a national park. So again, more papers. But stage 3 came when I came back to India and has been a journey from 2005 onwards. One of the things that I had in terms of dissatisfaction was a lot of the work we did, whether it was in Nepal or in Todoba or in Salaki, was I didn't live in those places. And so we produced a lot of policy relevant work. We also worked with the government to share our policy relevant work, and we had a lot of partnerships and engagement. But you still can't implement something if you don't live there consistently. And 2005-06, when I was back in India for a while, I started realizing that Bangalore itself is changing a lot, and we see a lot of urbanization impacting the way we live, our quality of life. And ecologists always traditionally have not studied cities for a very good reason, because they like to go to places. I mean, that's how I came into landscape ecology, because we don't want to live in cities. We want to go off into places that are more interesting to look at. And people who study cities don't look at ecology. So there's this gap in between always. And I wanted to do interdisciplinary science that was also co-produced, whether with communities or with governments and policymakers. And what I mean by co-produced is, not what I realized over some 20 years of doing this is the thing we were doing was wrong. We wanted policy impact, but we finished our work and then we handed it to the government or the policymaker or the community and said, here, take our work, it's policy relevant, go and use it. No one's going to do that. You have to first ask them, what questions did you think were important? Why do you want us to do this? What can help you? And so some of the things we do in cities, which I'm not going to talk about too much, but it's very simple. It's going to a road where trees are going to be cut and doing an impact assessment for the government or for communities. Or going to a lake and working with the government to say, how do you restore the lake so that people can use it, but biodiversity will not be impacted, right? Not things to do with space, I'm not going to talk about them, but things also importantly that don't necessarily need to papers. They're not going to be a big picture, big paper stuff, but they're very important to really establish change. So one needs to balance. You need to get your papers out and other things. So looking at the city, one of the areas I got very interested in was history and looking at geospatial technologies and history. So you have a lot of inscription stones. I mean, India is very data poor in terms of history because we are an oral society. We don't tend to record things. But we have inscription stones across the country that are found, which are different rulers talking about what they did. And from inscription stones, if you overlay the locations on digital elevation models, you can see how people come in. And again, I don't have time to go into the details, but I'm happy to answer questions or tell you about publications. But what you find in Bangalore, this is the DEM of Bangalore, is that there are two sides to Bangalore, the west and the east, and the west is hilly, and in the rain shadow of the Western Ghats, it gets very little rainfall, it's rocky, it's barren, it tends to have scrub and wild animals. The east is more fertile, gets more rainfall, gets people historically settled here first, and then moved to the hills. They did more agriculture. The kind of landscape is more prone to flooding even today. So it has consequences. It's history, but it has consequences on how we should plan the city and what we should do in terms of land use even today. And we don't think about these because what we have done is filled in the wetlands to build and blasted the rocks to build. So what you see is Bangalore, which is a flattish Bangalore today, but those of us who are older Bangaloreans know that it was an undulating city. But you can't defeat topography, right? Because you might have blasted the hills and changed the microtopography, but wetlands are still wetlands, and areas that are prone to flooding will still flood. And I don't know if all of you may not be from Bangalore, but a year and a half ago when we had a really bad flooding episode, the city was shut down for several days, and we had to take boats, coracle boats, into some of the areas to apartments and gated communities to rescue people. Yes. So it's important to study history because history has an impact on what happens today. And one of the ways you can do this very well is through geospatial technologies, which people need to use more. We also did a study of maps from 1885 to 2014 showing the loss of lakes, the loss of wetlands, and the loss of wells, because these wells were rainwater harvesting structures. The city also is very dry, and Bangalore is supposed to be running out of water. So the disappearance of wells in these maps is fairly dramatic, which you can, it's a good map to show policymakers and make them understand again the impact of these changes. But beyond that, we've also gone into looking at using the social ecological framework developed by Elinor Ostrom. This is work we did together on understanding. There are a lot of lake communities involved in lake restoration in Bangalore, and it's an unusual city because you have powerful community movements for restoration. So it's one of the cities that is most active in India in terms of community engagement with nature. But still, communities work with some lakes, and some lakes get restored, some lakes they make no progress. So we were trying to understand again why. And one of the whys is space, because the larger the lake and the number of other lakes that interface with that lake, the more difficult it is to restore. I mean, it makes sense because if you clean up a lake, but there are, let's say, 9 other degraded lakes throwing wastewater into it, it's not going to happen, not going to make sense. And if it's a larger lake, it's very difficult to desilt and drain, and it's very expensive, and then there are a lot of other implications of that. So using space again, to understand why certain lakes are very difficult to restore. It seems obvious in hindsight, but it's not something that anyone had actually talked about, and it has really important policy implications. Here, I would say in Bangalore, coming back to my original idea, it has been very satisfying because the work we are doing since I'm here in the city, research has been used by the court in pro bono and suo motu litigations, in public interest litigations, in community restoration, in media, by the government, whom we work with very closely for restoration, and in a number of other venues. Right? This also translates to something that you said in the introduction, that I do a lot of non-fiction writing with a colleague, for instance, and myself. So I've written 5 non-fiction books, and I find this is very important as engagements to society. I also run the Center for Climate Change and Sustainability at my university, which is very, the university itself puts a lot of its own philanthropic corpus money into public education. So we run, for instance, a climate festival once a year, which attracts over 10,000 school students, most of them from marginalized communities. So it's bilingual, Kannada and English, and it goes to different parts of the country where our organization also works, the Zimpimji Foundation, which is Hindi, English, Kannada. So this year will touch about 40 to 50,000 students in different parts of the country. And I think these are the engagements that we need to do. So to come back sort of full circle to my talk, I think we are at the era of the Anthropocene, where we see climate change, we see biodiversity collapse. How many of you have seen the latest report on global tipping points, which came out? It was all launched at the side event of the COP. And it talks about the number of tipping points that we will see, which includes the Amazon, the ice sheets collapsing. We might not, the Amazon seems very distant to us, but what we don't necessarily realize as a country is that when the Amazon goes, the weather impacts will be severe for us because the El Nino, the La Nina, all of them will be out of whack. And India's still such an agricultural economy, and we depend on agriculture to feed ourselves, and all of these are going to have implications on us, right? Also, the planetary boundaries framework, which the Stockholm Resilience Center and other people have developed. This year, there's new research that says that 5 of the 9 planetary boundaries have been exceeded, 2 more at the danger stage. So I think there are a lot of things going on with the world. The next 10, 15 years will be critical in us getting things back on track or not. And why are we here? We're all geospatial researchers with interest in geospatial technologies, yes, but we're also researchers and residents of planet Earth at the same time. And I think it's urgent like it has never been before for us to interact with society. So I would say coming back to this, for me, what has been a learning is multidisciplinarity is not enough. Interdisciplinarity is not enough. What we need to do is transdisciplinarity, co-produce, talk to people of various kinds, move beyond our comfort zones. Right? So communication is something that I do a lot of nowadays, and it's not something that I was trained for. It's something that I've trained myself for. Other things, each of us has our comfort zone. We might like teaching the very young. We might like writing about things. We might like engaging with society. We all have our comfort zone. I remember, so again at the side event of the COP, one of the 1,500 climate scientists just signed a letter urging other climate scientists to be activists. That's in some people's comfort zone, that's not in some people's comfort zone. But I think there are many ways in which we can contribute, and all of that does not require extreme positions. Much of that requires engagement and working with people, because I think we're all very well aware of the challenges. It's just that we have different ways of addressing, but we all need our tools and our strengths to come to rise to fore. So I think that's where I'll end this keynote with the urging that in the era of the Anthropocene, can we all remember our role as members of society along with being scientists, and how do we engage thoughtfully, constructively, collaboratively as members of society to strengthen everybody's hands to solve this collective problem. So I'll stop here, and I'm happy to take questions.
Yeah. So very nice listening to you, and then I think I was not wrong, and when I was suggesting her name for the plenary talk. Yeah. So any questions from the audience?
Thank you very much. It was a fantastic talk. Right now in India, in particular in Bangalore, we see, of course, while coming from the airport also, that a lot of hills, they have been blasted and it's all flat now. What are the implications of this? Bombay also is going through that, because of the development, so-called development. So what is the implication of that? And at this point in India, what do you think is the most urgent thing that needs to be, addressed and people should be aware of and needs addressing by the scientists?
I think microtopography changes in cities are huge, and we are now 33% urban, but some estimates say we'll be 50% urban in the next 20 years. So that, I think this 20 years is critical. And so what we have reasonable studies in our big cities on where we need to go, but where we are lacking is this big integrated planning perspective. And so there's a lot of work I think especially geospatials can do there. For instance, in Bangalore, a lot of the work is being done in terms of the policy space in looking at old maps and saying here is where the drainage networks used to be, so we need to restore them, and we need to do that. But we've changed the microtopography with the blasting of the rocks and the changing of the drains and things like that. So if you restore just the old drainage system, you're not going to prevent the cities from flooding. And we can do a lot there in terms of dynamic studies of what the microtopography is now to suggest how do you and the land use. You are not going, for let's say there's an apartment complex that has 10,000 people. It is not feasible to say demolish it and create a drain. So nobody does it. But it's still there in the plans. And so there's no alternate drainage. And so what we need to be doing is putting the land use, putting the microtopography, trying to figure out how to drain the city, how to make sure rainwater harvesting is done, where trees need to be planted to protect against pollution, where green spaces need to be there for accessibility so that everybody has, Europe is trying this 10, 100,000 or something like that. Basically, every 10 people should have a park that is 100 meters from their house and something. So can we think of something like that? Where are the open spaces? There's a lot of work. especially in the smaller towns and the peri-urban areas. Because I think realistically in the heart of the city, what has happened. Bangalore, Bombay. But where problems are happening in Bombay would be, for instance, the new airport. You know, you're building a new airport on the seafront by destroying mangroves in an era where by 2030 it's going to be flooded and the mangroves would be your protective wall. So those are the things we need to be highlighting, because this is where we can actually make an impact. And we have a few studies, but imagine, I mean, Geospace has the capacity to do such studies across the country very quickly now with the kinds of big data approaches we have. I think we should be focusing a lot more there.
Madam, many thanks for a very insightful talk. I'm also a great fan of your writing. I just saw in one of your slides, you had shown that the count of wells have gone down in the city of Bangalore. But at the same time, we also know the count of bore wells has gone in a very exponential way. And it's kind of over-abuse of the groundwater. So how is this actually impacting the overall ecological balance?
Impacts it in a number of ways. Of course, as you pointed out, what bore wells do is reach geological water, so it was accumulated over centuries often, and we're removing it and it cannot recharge because it's below the stone surface. What wells would do is recharge the water very quickly and prevent flooding. And so that balance has been shifted, but also a number of other things that we don't know. For instance, when you have a lot of bore wells, you have subsidence, and those are questions we have not studied. So what we need is a good ground. Again, this is some place that geoscience can play a role, because we don't have good geological maps of any Indian city. And we need that to understand things like where do you put the bore wells, where do you put the wells, how do you actually restore the city.
Maybe creating that map is the first.
Creating a dynamic map is the first. What we have is static maps, you say. Absolutely, yes, absolutely, absolutely. And one with government collaboration and validity, yeah. Yes. No, very true. Because see, what happens is people as individuals create maps, but that has no government validity, and it should not also, because you know everybody can create a map for their own benefits. So something that is a sanctioned quality map, which is dynamic, is absolutely the first thing, I think.
That map would have other parameters also.
Yes, exactly.
Many other things, and topography as well as maybe the bore wells or whatever.
Everything is yes. I think now we can go sub-meter, so we should be going sub-meter of the entire country, exactly. So you can zoom in and zoom out.
Okay.
Very, very again outdated is with the urban kind of, because of urbanization outdated.
Okay, thank you very much for this inspiring talk. It's been very nice. So I come from remote sensing. I build the satellites and design the satellites. So nowadays we have many technologies. You have discussed about Landsat, which is, I mean, on the top. But we have radars, we have lidars, we have things that look at the atmosphere. So my question is, from your point of view, which has to be the role of remote sensing in the future? Because beyond India, I mean, globally, which has to be the role? Because I can be in my silo, designing my satellite with measures specifically something, my zone of comfort. So from your point of view, which has to be the role of remote sensing in the future? Not the future of the remote sensing, because we will develop the technology, but I would like to know your opinion about where should we direct remote sensing beyond the design of a nice technology to measure a particular thing?
So to me, that one thing would be to design technologies then for interpretation that would get out of experts' hands. Because if I think of the effect that Google Maps or Bhuvan in India has had on common everyday users in helping them understand how space happens. I mean, I see this when cities flood. You know, if you see Calcutta flooding or Bangalore flooding, the first thing on Twitter or any social media you'll see is users trying to look at their areas and saying, this is why it flooded, this is what we need to do, and here's this drain, here's this blockage. And often with LiDAR or, you know, the more, nobody knows how to use them. And so how do we get out of that? Because the problem, again, with the Landsat or I mean, it's only one perspective. We're not getting the 3D, we're not getting the below ground, we're not getting the above ground, the atmosphere. But can we get all of that integrated in a platform that's really simple for users, very intuitive? And it's not so easy, but I think that is really, if you want change for the Anthropocene, that's what we need to do so that everybody can actually use that data.
Okay, thank you.
Nobody has question. You want to ask?
And there's one there also.
Yes, ma'am. Great, insightful talk, as expected. Thank you so much, Bo. So I have a question. So you did mention about the lake restorations and all of that, and you also mentioned that usually the scientists don't study ecology in cities, right? So just mixing the two up, right? So now we have restored lakes, which has caused a change in the ecology, right? And this is not the ecology that we had earlier, right? So do you, is this something that has to be studied, or does it have widespread implications? What are your thoughts on that?
So I think everything needs to be studied because it's such a, we know so little that everything is really a black hole of information. But the main thing is that all cities across, especially in the global south, but across the world, are turning from, I mean, all the water bodies in cities are turning from seasonal rain-fed to perennial sewage-fed. And that completely changes the ecology, that completely changes the interlinkage, the water flows, the implications for soil and everything else, and for human health. And that is not something that we know anything about. For instance, microbiota must be completely changing. What has changed? We don't know. So, yeah, lots of unknowns.
Yeah. Thank you for the nice talk. Just one query. You touched upon the hierarchical reasoning methodology, right? Going up and down.
Mm-hmm.
So, couple of points on that. How much, when you change the cases or the case studies, how reproducible was that approach, or how much of handcrafting it needed from one kind of case to another? That's the first part. The second part, you showed very nice case of ecology, GIS, and anthropology. So keeping GIS and remote sensing constant, what other fields do you think this kind of, or what other use cases this kind of hierarchical reasoning approach would help? So.
Broadly, I found it very you can easily take it to other situations. Sometimes you need to go more than that one level above or below to get an understanding. So that is where the handcrafting is required. You know. So for instance, if it's climate change feedbacks on lakes, that's going multiple levels higher, because you need to understand how rainfall changes over time can impact the way you plan your lakes for long-term resilience. And that's really going several spatial and temporal scales ahead. Right? So. Your second question was what are the other? So history, for instance, is a case. I think we really need to start looking at history, especially to communicate to people, but also to understand why we are in certain patterns today. You know, why our vision of development is so flawed that it is actually not taking into account ecology at the core. And so many things like that. I think remote sensing, old maps, adding GIS, adding archaeological insights into what are the features below the ground that also shape things. There's a lot that remote sensing can do there.
Thank you.
There was a question here and one there, and then we can come back.
Hello, ma'am. I'm Almas. I'm a PhD scholar in IIIT-Bangalore. So that was a great talk. I want to ask, based on the ecology background of yours, so there are a lot of construction happened on lakes and ponds in Bangalore and Chennai. So because of which urban flooding has happened. So what are your intakes or insights on how we can undo those things, because we cannot undo the developments. Based on ecology and environment point of view, what we can do to at least reduce those impacts?
An excellent question. I think one of the things we need to do, space is short, so I'm going to give you a very quick answer, but we can talk later, is to get creative. In a city, we've lost some places. Can we create floating wetlands on plastic boats and rafts? Can we deconcretize the sides of lakes? Can we have policies to protect our wetlands? Because we have very strong policies to protect lakes and water bodies in cities, but not the wetlands behind the lakes. And so that is really a big problem in terms of you can't have the healthy lake or a pond without a healthy wetland ahead of it. And so wetland policies outside cities are very strong, in cities they're weaker. So there are a lot of things that in the specifics. But there are also things that we can do in terms of micro-injection points. For instance, if you had a road or an urban large building, if you created these very tiny well-like structures for rainwater harvesting, so you just take a deep 4 feet, half-inch thing and put it, you can actually recharge groundwater that way. And those are ways you can balance. And there are a lot of hydrologists. I'm not a hydrologist, but this is things that hydrologists have suggested so that you can actually, and this is where again spatial analysis can be useful. Where do you put those? Because they're expensive. in terms of having their maximum impact on reducing flooding and increasing groundwater recharge. There was a question here.
First of all, thank you for a wonderful and inspiring talk. My question is related to disappearing islands, and there is also threat of some coastal cities in India disappearing. So, are there any studies on spatial studies and remote sensing on these aspects, and are there going to be corrective actions in our country especially?
Corrective actions, I think, are a larger conversation, but studies is the first step definitely that we need. There are some studies, for instance, Lakshadweep, there was a very good study which was done a few years ago. We are doing something on Bombay. I know other groups, World Resources Institute is working on flooding risks in Chennai and Mumbai again. So there are a few groups, there need to be many more. Because that's the first step, to approach people or the government and to have that dialogue and to look at what can the city do for climate resilience. You first need those studies. So you need a lot of those studies.
Good morning. Thanks for the wonderful lecture. You covered from regional to the micro level, considering the economic point of view, which is an important. But my question, what I wanted to ask you, see, we have a lot of data. It's not getting implemented at the ground level. That is what it's happening. How will we look into the economic point of view and implementing? What are the challenges which, especially the Indian conditions, which will be look into it? Because you, especially from the Bangalore point of view, it's not that we have dearth of data. Huge information is, but not getting translated to the ground. Where are the bottlenecks? Maybe you can throw some light on it.
Sure. So again, a very complex question. It will differ from place to place. In my experience in Bangalore has been firstly, that long-term engagement matters. You need to be from the place, and that is really one of the things I learned. You need to be there, consistently talking. One policymaker changes, another one comes in. They remember that you've had this dialogue, that you've always been constructive, that you want to engage. And that engagement, that positive approach really makes a difference if you're there in the long term. Secondly, to work with all kinds of groups. So government is now very willing, always been willing to work with communities because they can't do everything. It's not possible for them to be everywhere. Communities can do some things. They can't sanction illegal offenders, and they should not be given that authority also. So there needs to be that very close collaboration. If we as academics work with local communities and work with the government, I think that's a very good synergistic combination. And maybe with corporates, where the areas to work with corporate groups also, because they have such an influence. So this three-way combination with the academic universities being the nodal, because in that sense, our data is objective, our viewpoint is objective, we don't have a vested interest. So we are a very good neutral place for everybody to congregate, and we can strengthen policymakers' hands through this. So but long-term engagement, nothing will happen if you just want to come in with a short project.
Yeah, I have just not complete two questions, 1.5 questions. So the first question is about, should there be controls on allowing people to have boreholes, like bore waters? I have seen in a country like Malaysia, except in temples, they don't allow any boreholes to be put that, even open wells. But we don't have such policies here, and should we really enforce governments to implement such kind of things? Because we recharge a lot of water in our campus of 35 acres on Mysore Road. But next to our campus, there is a Sri Guru bore wells, and that fellow tankers of tankers he used to sell. And we say, what is the use of storing, recharging here? And that fellow is just pumping out the water. Should there be any control on that? Yeah.
Absolutely, there should. I think government has been talking about that for a while. Our problem actually is we don't even have data on this. So this we have been looking, nobody has data because you need to apply for the electricity permissions, but apart from that, you don't need any permissions. So even government doesn't have data on how many bowels there are.
Excellent. Excellent. You also recently made an announcement that some studies on mountains that you have called people for participation. Had I been angry enough and I should have joined that, but so you want to highlight something here?
Absolutely, and I'm glad you pointed that out. So like I said, we run the Climate Festival series at Azim Premji University, which is every year we have a different theme. It was Rivers of Life and Forests for Life. This year it's Mountains for Life. And our approach is it's a festival for the young, by the young, because we feel that when people like us come in, we tend to preach to the young and they don't take it very well. So it's very nice for them to have young people giving their exhibits and talking, and it really helps to communicate that way, the energy and the enthusiasm. So we have an internship call which is open across the country. Anyone below 25 is welcome to come up with a project. We will fund them to go and study the mountains. We'd also like, that said, we also have curated, because this is mountains and important work is going on in the mountains. So many of you who are from scientific institutions, I would love to get an email from you. We would also love to approach your institution and get some details about the work you do and your insights. So we can cover that in exhibition material along with these internship calls. So please look at the University Mountains of Life webpage. You will find all the details there. Also art internships, again for the young, who can curate art works, and because we find that that really helps to communicate on mountains. So.
Thank you very much. And I felt initially when I was very young and I used to study ecology, ecological physics, mostly the papers written by Ehud Meron from Bar Ilan University in Israel. He used to scare us, the kind of mathematics he used to use about ecological predictions and all that. She made ecology so simple, and he has enlightened all of us in a much simpler language. Thank you so much, ma'am, and so it's an honor to have you here. Thank you very much.